So welcome everyone. Thank you for attending this Value Voice. We have today Bruce Lenzer, an excellent speaker who will be talking to us about the future application of AI and value engineering, because AI is a hot topic right now. And we've got lots of questions about whether it will replace value engineering, will it augment parts of the value engineering job plan? So this presentation will attempt to framework what the potential advantages AI will bring to the value engineering discipline and facilitating teams for value creation and improvement. So I'll just say a brief word about our speaker, Bruce. Bruce Lenzer has over 30 years of experience in conducting and managing high-performance, multidisciplinary teams to solve a variety of complex technical and organizational challenges. As you can see from his shared screen, he's got many certifications. He's a life certified value specialist. He's a fellow of SAVE International. He's a certified quality manager of organizational excellence and a certified lead auditor with highly developed expertise in value engineering, value analysis, life cycle cost analysis, function cost modeling, strategic planning, quality management, business process improvement, project management. So he's done a lot. So just to skip and go straight to the money part, his value improvement savings and avoidance from all strategic value improvement initiatives have exceeded several $billion. So we have a very interesting speaker, and Bruce, I will let you carry on now.
Thank you, Adrienne. Appreciate the introduction. And yes, it's been an interesting career with value engineering, value analysis, value management, not just in one particular discipline, but in many different disciplines, and seeing how this process is actually applied in a number of areas where you would typically think, I don't know that value engineering is a good tool for solving this problem. In reality, it can solve a lot of problems, especially with the right teams, the right people involved in working the value engineering study, whatever that subject of study might be. So yes, the AI area has been, artificial intelligence has been a very hot topic. As Adrienne was explaining, there's questions of, is it going to replace value engineering? How's it going to play? Is there some synergy between the two, the technologies that AI brings and that value engineering brings together? And so that's kind of what we're going to talk about this evening. So first of all, what is it? It's a field of computer science, and it uses technology to create machines expected to mimic human intelligence that includes the ability to see, translate spoken and written language, analyze data, make recommendations based on programmed data analytics. So this is the general expectation for AI. It does encompass other disciplines besides computer science, obviously data analytics and statistics, hardware, software engineering, linguistics, neurosciences, philosophy, and psychology. Now, what's interesting is in the latter two, the neuroscience area, philosophy and psychology, that area, that realm is going to take a considerable amount of time to program in algorithms and other tools for AI to work as an autonomous unit or entity. That's going to be the hot area from now on getting the robotics really to do the things that a human can do. And I'll explain a little bit more about that as we go along here. So AI uses algorithms, matrix algebra. There's different types associated with human intelligence that include pattern recognition, decision-making, learning from experience. It drives search engines. So all of us are familiar with searches that we do now on the internet or on our phones. And that searching algorithms that they use now will basically retain the information that you've searched, and it learns what you're searching for, And so it gives the algorithms and the capability to present to you new information based on what it thinks you might want to see. So this is what we're most familiar with when we think about artificial intelligence. So what is an AI algorithm? Well, it's the instructions to respond to the data presented. It uses numerical linear algebra, and it's the steps to solve a problem, and it must be applied when programming AI. And when I undertook this study about AI, I didn't realize it, but I do now. There's 9 types or 9 types of these AI programming algorithms that can be used. And so these are sorting, greedy, backtracking, divide and conquer, brute force, recursive, searching, which I've just mentioned we're most familiar with, dynamic programming, and randomization. Now, I'm not familiar with all of these. I've just learned a great deal about this whole area of AI and how these different tools are working and how they're working in the background, how the programming is done. In my early career in college, we had to do operations research, and we had to basically build matrixed algebra algorithms to solve problems. And essentially, that's what a lot of these do, but they're designed for a specific kind or type of purpose. So what are the limitations of AI? Well, one of the things that's interesting is it cannot replicate human creativity. Now, that might surprise some of you because you can go in and ask it to write or develop a picture or maybe write a poem or do something creative. So there are algorithms that are out there that can do some of that type of thing. But as far as the actual right side of our brain, the right creative side of the brain, the AI algorithms are not able to replicate the human creativity that we as a group can do both individually and as a team. AI can't achieve goals. It can't conceptualize, plan, or create. It can't innovate. It can't feel. It can't replicate empathy or emotional intelligence. And it can't make any decisions or inferences on common sense. So there may be data, empirical data that the system is processed, and there's a lot of logical information, and it's very compelling. It's very solid in its analytics. But then when you start looking at it from a common sense perspective, you might think, well, yeah, but there's all these other non-quantifiable types of things that are involved in this solution that may cause a problem for us to try to implement it. Yeah, it may save us some money or it may improve value, but there's going to be some other challenges with it. It doesn't have that sort of capability yet. I'm sure there may come a day when it can do that, but there's a lot of challenges surrounding that aspect of AI. Many of you know, of course, the person by the name of Elon Musk, who owns SpaceX and Tesla and all these great new companies. And he has some concerns as well as some other technical experts. And one of the things that they've already come across is that in trying to program AI in the area of neuroscience and psychology is that there's a problem in the context and nuances between language and communications. So as an example, we might say something sarcastic and the computer AI doesn't know whether that's sarcastic or not. So teaching it what is sarcastic or not sarcastic is a challenge. So there's a limited understanding of these contexts in the different languages. One of the main concerns is it perpetuating and amplifying biases. And basically the data is trained in such a way that the algorithms have to know what's true or not true, what's absolute or what is not absolute. So, or what's omitted, what absolutes are omitted. So the programmer has the capacity to take these algorithms and program them in such a way that whatever truth they impart into this algorithm is the truth that it's going to use to process a particular data set for solutions and so forth. So that's an area of concern. It can't make ethical or moral judgments. This is pretty typical. And of course, our old acronym from those of us that have been computer programmers in ages past, garbage in, garbage out, GIGO. Whatever you put in is what you can expect to get out. And so there is a need for quality checking any of these types of AI systems or systems that might be used to apply in problem solving as they develop. So it's interesting to note that the fastest supercomputer today is at the United States Oak Ridge National Laboratory, and it can process 1 quintillion calculations per second, and that is fast. I mean, that's it's hard to even explain, how fast that really is. But those of us that have been in the computer world and know what the smallest computers were that we worked on back in the day, and
So unhappy.
are just it's almost unfathomable the capacity of this type of computer. Anyway, computers are very good at data processing. We all know that, and performing logical tasks. There's a lot of really good things that computers do well. If we look at the computers versus the human mind, we've got a totally different computer. It's biochemical, bioelectric, and it's a parallel processor. We have essentially two computers, the left hemisphere, the right hemisphere of the brain. We have 100 billion neurons, 100 trillion connections between the two hemispheres. We have the capacity to process 20 quadrillion calculations per second. And so we even have in our brains today the ability to process this fast. And that's because we've got visual information coming in, we have verbal information coming in, we have nonverbal information coming in. We have all this information that is coming in all at the same time that our computer, our computer mind is processing. And so we're good at prioritization and understanding the world. This is going to be a challenge for AI to understand the world because of how history is being rewritten in some cases. So history is programmed into the systems as it is today. And most of it, I'm sure, is factually accurate, but there are some things that are factually inaccurate. And then there's new information that's coming into play where certain pieces of information are being not necessarily replaced, but rewritten. So this is kind of an issue surrounding AI of concern about the actual facts and how it processes those from the known world, and how we as humans can process that same information and what the understanding is of the world. So earlier I mentioned that the human brain has the capacity to create, and that is one of our strengths on that right hemisphere. So imagination and generating new ideas are one of our premier strengths over and above a supercomputer that does AI type of work. We're good at achieving goals, and we're good at the common sense aspect of analyzing something from a common sense perspective versus logic. So we don't throw the logic out, but we certainly want to make sure that whatever solution sets come out of any AI types of programming do in fact make common sense. So we as humans have the capacity to do that filtering. So most of you know what value engineering is, that it's an organized team approach to evaluate necessary functions for the lowest cost of ownership. It promotes substitution of less expensive materials and explores alternative designs and methods. We don't sacrifice quality functionality, maintainability, safety, those types of attributes we don't touch. We don't do something that's not safe, or we don't do something that's going to reduce quality. Now, that has happened in some VE studies. There have been some issues with some historical issues with others doing VE, even some that were not certified, saying, well, I did VE on this and we saved this much money. Well, VE doesn't necessarily just save money. It may actually increase costs depending on what the customer wants. So it is not a cost-cutting tool. Of course, it can be used for that, but that's not what it is designed for. It is designed to improve value, and VE can add cost. So as an example, James McCouche, a colleague that's on with us today, he and I were involved in doing a couple of value engineering studies recently, and for an added cost of around $400,000 up front, the client could save $4 million over the life cycle of these two projects. So that's an example of taking and adding a cost to a project that's going to benefit it long run from its life cycle cost savings. So adding cost to products is not an issue for value engineering. It has come up in several of the studies I've facilitated, and so a value specialist should not be concerned with or afraid that oh my gosh, this idea is going to add cost. We always want to look at any idea that's a good idea, whether it adds cost or not. And if it does add cost, what are those benefits? What are those quantifiable benefits that added cost will bring? So I mentioned earlier, I've been talking a little bit about the left brain, right brain. And so certainly AI has the power advantage over our left hemisphere of our computer in our cranium, because it can do these things logically. It can do the analytics, the data analysis. It can do those things at an extremely high speed, and does those things very well. And so where AI is deficient is in the area of the creative and imaginative areas, where that is part of the whole value engineering paradigm, is for us to look at all the alternatives, look at different ways to do things, to use creativity to do something different, to add value to a product, project, service, organization, whatever it may be. So from a human computer perspective, this is where AI, again, it's deficient. Not that it can't do some of these things, and probably will do some of these things in the future, but the strength today in team membership for these value engineering studies really lies in the benefit of our right brains and applying creativity. Could go into more of that information about the two hemispheres, but again, the perspective, imagination, and being able to think and visualize differently. One of the companies that I worked for, I trained 45 value engineers with Samsung Electronics, and we took two products that they had said, oh, we value engineered these products, and they're great and wonderful, and we've got 5 years of production left on them, and we're going to make X amount of dollars, even though we're having to reduce the cost because of competition. And so we did a value study on products that already had been value engineered. And those two studies alone resulted in each of them coming out with $100 million value improvement over that 5 years, by doing some very simple things and providing extra value or additional value to the customer at no cost to implement some of those changes. So that was a case where, you know, the team members thinking everything had been done hadn't been done. And one of the engineers came up to me during the session. He said, Mr. Lenzer, he said, one of the things I'm beginning to learn now is you're asking us to think differently. And I said, that's exactly right. You want to think differently, because in certain cultures, design and coming up with a design and a product design is very specific and very personal, and a lot of effort goes into making things perfect. And but we get out of that perfection paradigm, not that we throw perfection out the window, but we want to look at things from different perspectives and learn how to do that as a team. And so that was an interesting comment from one of the engineers. So if we look at the value engineering team brain power, if you stop and think about that we have 6 at least team members, up to 12. Several of us on this virtual meeting today have facilitated teams even much greater than this. We've had teams of 100 where we had to break up teams into 10 teams with 10 facilitators and 10 scribes because of the size and scope of the project. But if you stop and think about it for a moment, just even with a team of 6 to 12, and a team that's coming together mostly for the first time, some team members are familiar with a particular technology, may have done some value engineering work before together or separately on different teams. But what you're doing is you're fusing together a new supercomputer for that topic, that subject of value study. So we're taking these brains that we have, these supercomputer brains that we have, and fusing that together into a new supercomputer, each processing at the high rate of speed and calculations per second, as I talked about earlier. And we're multidisciplined, right? We don't have a single discipline team, so we don't have a computer, a person in the sense of a computer that's the same discipline, electrical. We have electrical, mechanical, whatever we need in the way of a discipline that's represented by that subject of study. We need to have a subject matter expert on the team to help us with that study. So thinking of it in terms of different disciplines, different subject matter experts coming together, working together on this unique supercomputer team, it is an opportunity for us to witness and see the tremendous work that certain unique teams like this can really do. So we're really talking about a very powerful parallel processor between all of these individuals working together as a human computer, if you will, working on these problems. There's, of course, the advantages of dynamic interaction, and it has just been mind-boggling to me, and I know others that are on this same call that have experienced the magic of just phenomenal opportunities that have come out of these value engineering studies, and how these teams have produced just unparalleled results. And that's not just because of value engineering. It's how we've applied the tools and how we have helped this unique multidisciplined supercomputer team to perform its best as fast as we can. So we want fast results, but we want that supercomputer team to come up with really high quality, high end results. And that's what we as the facilitators are charged to do, is help facilitate that computer of people to come up with these phenomenal results. There's some other concerns surrounding AI. In certain aspects, it is becoming more powerful. It might be able to mimic human consciousness. That is still debatable, but not reality. It's difficult for a machine that is just familiar with ones and zeros, on and off conditions in the computer and in the machine language, to really be able to have enough information to differentiate reality from non-reality. Will it be self-aware? We don't know. I mean, it's possible, I'm sure, that any of these AI systems because eventually become self-aware, but I don't think that's anytime in the near future. There is a rate of advancement, and we have to remember that in any programmed system, right, whether it's AI, whatever is programmed drives what that AI is going to do. And so, again, it gets back to the facts versus the truth, what facts are programmed in, what algorithms have been prepared for the calculations, and are those factual? Is the information factual? There is an uncertainty if AI can work on its own as its own team. So as we've just talked about, a team of a supercomputer team of people working together on problem solving using value engineering, a computer to step up and be a facilitator to facilitate team dynamics and all these different things that are going on dynamically with a team. That is a lot of programming, and that's a huge challenge for someone to come up with a robotic entity that could actually facilitate a team. Can that come about? Certainly. Might it happen? Sure. It's very, very likely they're going to have something of that sort. But I'm not sure how long it's going to be before we see that. I think that'll be a while yet. But AI could play some different roles on teams. That is very possible. I don't think I don't think team members can be completely replaced, if you will, by AI. AI serving as an example as a mechanical or electrical engineer. Certainly, the tools need to be operated and quality checked by the disciplined engineer, whether it's mechanical, electrical, or whomever. There needs to be that sort of quality checking that would go into, but I don't see that team can be completely replaced by an AI supercomputer. How can AI and VE work together? Well, I kind of looked at this, and certainly we've got a brain trust of our team, which is a unique supercomputer. In the information phase, and James and I have done this already. A technology had surfaced that we didn't know much about it. Okay, and so we were able to use ChatGPT, I think it was, or one of the tools, to look at what this technology was about, and so it became a tool to educate the team members, or some of the team members, before we got too far down the path of our study. So certainly the searching algorithm types of AI tools can help us in educating the teams and understanding technical aspects of the subject of study. And I think that's a big advantage, because when we bring in people like procurement or other non-engineering disciplines into a value engineering study, it helps for them to understand the technical information or some of the technical aspects of what the team is dealing with or may be dealing with in the area of the value study. Relative to function analysis, certainly the traditional function analysis, I believe, can be AI driven. That's simply because we take a cost estimate, we take the functions that are provided by the cost estimate, or vice versa, and those cost elements can then be sorted easily by doing a Pareto sorting. So the sorting algorithms can do that. Of course, an Excel spreadsheet does that now today. So do we need AI to do that for us? Well, not particularly, but there may be some opportunities to look at other dimensions of cost modeling and of function analysis that might be worth looking at as far as expanding the algorithm capacity to make the basic function analysis a better tool, a more advanced tool. Function analysis system technique, which is the diagramming and modeling technique, which is driven by a facilitator and the team. Now this would take a lot, I think, of effort to develop the algorithms in order to put together an actual diagram. Can it be done? Sure, I think there's the potential it can be done. How? That's got to be solved. And which algorithm type tools use that would have to be looked at. But certainly searching and randomizing some of these algorithm types would be helpful in putting something together. So if we take as an example I'll mention it again, the function I tool that we have on the Miles Value Foundation site, where you can go in and look for, search for certain types of functions and functions to product or whatever. There could be a starting point where you say, well, we believe this is a basic function, and the team agrees to that, or the facilitator drafting this function model could say this is the basic function, and the randomized functions that have been identified for the rest of the work could be in a database or in an algorithm where the system could go out and say, I understand what these specifications say, or this project is articulating what we need, and it could go through and then make some choices and decisions and maybe present several different versions of a function diagram that one may be better than the other, of course, but it could give you some examples or some sense of working one particular or several different diagrams, that one of which might be better than another. It's the same thing as we've taken the FAST tool, and we've taken and broken up a few teams to go do a FAST diagram on the same subject, and those teams come back in and present the function diagrams that their teams have assembled. And what we learn is they're all different. They may have some similarities, but they're not the same. And so now the teams in a couple cases where we've had this happen have sat down and looked at them and said, gee, we think team two's function diagram is really it really is more representative of our project or our product. And so then the other two teams' materials can then also be used to refine and help build the function diagram that the collective team believes best represents their product, project, process, service, whatever the subject of the study might be. One of the things that I do want to emphasize is the FAST diagramming has been one of the tools that I have personally experienced opening up the right hemisphere of the creativity of the team. And this has happened so many times, and it's just amazing to see what happens. And it's because of how we typically put the function diagram together and how that logic works back and forth, starts the thinking process, starts the neuron process of a team member thinking differently, because they're looking at how, and then they're looking at why does this particular function occur? Why and how do these things happen? How do they occur? How do they logically fit together? And then that starts generating some neurons in the brain, which then triggers some creativity. I have seen tremendous creative solutions come out early in the function diagramming phase of the value engineering study, where several of those came out that survived the evaluation phase were just that they were tremendous, and it was all because of the function analysis system technique diagramming tool helping the teams open up the creativity to solve their particular challenge. So again, to identify functions, actually we haven't talked too much about that, but there's some algorithm types that can help us with that. And I think that's a potential of maybe a new algorithm dimension could be developed based on FAST, just thinking about how it works and how we put those together. again, that's kind of far out thinking or strategic thinking, but there may be some opportunity there. In the creative phase, obviously searching for creative solutions using AI tools can help us look for particular technologies or whatever that might help spur on some creative thinking. We don't want to leave out trees, the theory of Russian inventive problem solving. That tool has been good, and I've witnessed and experienced it being applied to some pretty significant technical problems that it's helped solve. Now it takes longer. Historically, it takes longer to apply the trees tech tool, but we don't want to throw it out either. We want to consider, okay, maybe for the future there's some possibility for AI tools to be integrated with trees that could actually be of benefit to that product as it may be applied to problem solving or creativity. In the evaluation phase, there's a number of algorithm types that could be applied based on the evaluation and selection criteria, the filtering and comparison of alternatives, and of course, the supported AI data calculations. Again, the supercomputers of the day now that we have that are fast, if we have the algorithms that can generate and process the data quickly, then certainly I can see where in the evaluation phase, some of the tools can certainly be applied effectively, and to be able to simulate some of these concept alternatives more real time and dynamically, rather than having to think through other aspects of that concept and that alternative and how that's going to work. The development phase, evaluation development is a handoff there. So I think the same tool sets we just looked at from an AI programming paradigm would be partially some or in part use the same or similar tools there to help us with the development phase, because really all we're doing is we're taking now what we've evaluated and we're putting together the information on some forms to fully develop that proposal. So there would be manual intervention, I'm sure, upon the part of the team, but we can also have or consider that there may be some AI algorithms that between evaluation and development that could help us with populating certain parts of the proposal for a particular idea. To me, the team also needs to QC the solution set again, because we're looking at, because of the way the human computer works versus a traditional computer, we still need to do some common sense sort of screening and quality checking to make sure that, hey, you know, what AI has helped us produce here, does it really make sense, and is it something we want to move forward? So I don't see us getting away from doing some form of quality checking in the end. The presentation phase, my view is value engineering is a team effort. It's not a computer effort. It's not a computerized systematic effort. It's a team effort. Yes, we use the computer tools. And so I believe the team should present that. Now, AI can package and sort and even translate and verbally speak the solution sets and present the outcomes from the value engineering study. That can certainly be done, and that may be a choice by some teams down the road. But I think it's best the team present the solutions. I'm always of the opinion that a value engineering study is not my product; it's the product of the team. So the team owns that product, and they should be the ones that are sponsoring. They have to live with the results, right? And so they need to be the ones that step up to the plate and demonstrate that, hey, we believe this is going to work, and that buy-in and that ownership helps in the end to make sure that the client gets their solutions implemented. So in conclusion, I don't believe AI is going to replace the team. I'm not seeing that yet. And I could be wrong. I mean, but I don't see that in the near term. It certainly supports the team. Obviously, augmenting that left hemisphere functions for the team, I think, is a tremendously powerful component to leveraging AI. It may help accelerate the VE process, certainly improve quality of results, and it will augment the discipline. So it might replace a certain team discipline in the future, maybe, I don't know, but I'm thinking now more in terms of, I believe we'll still need the actual mechanical, electrical, civil, we'll need the engineer, we'll need the specialist there to work the solution sets or to work through with the AI tools, the solutions that it helps support to create. So there may be some new opportunities here. As I was putting this together, I thought, maybe there's a new value engineering paradigm that we could possibly consider developing. And this new paradigm would be based on what artificial intelligent tools could be packaged together to help us during these different phases of the job plan. And so there's, I think, some potential here. Not saying that there is or isn't a project here. It's proposed that we might consider this. The FAST tool, the function analysis system technique tool, would be kind of intriguing to me because I've seen how that's worked so well, and it would be kind of interesting to see what AI might be able to come up with based on some of the information we would be able to feed an AI FAST tool, if you will. So it might be there might be some expression of interest. I'm not saying there is or isn't at this point, but the Miles Value Foundation and Institute would be certainly open to looking at developing some of these new technologies and techniques. That's part of our mission. Obviously, industry partnership and participation would be paramount. We would want definitely to have some industry partnerships, and of course, academia and grants. These things would need to be looked at as well. So this was just as I put the presentation together, I thought, rather than just talking about what might be or what could be, there's a potential for a project that could be considered for the future. Just a real quick plug for the Miles Value Foundation. It's available. Most of you know the address of www.valuefoundation.org. Here we do host the function iTool. We've had a few problems with it. So if you find that when you go into there and you're having a problem working with it or there's an issue with it, let us know. But that actually might be the first tool we take a look at and ask ourselves, is there something more broadly with AI that we might be able to develop with functions and with function analysis? The Institute is new. We just launched that as of the SAVE Summit back in June. And along with that, we launched the Function Models Guide, the Function Models Guide course and book, which are available now. And also just recently, the Value Methods Theory book for college courses. And so these are our new things that we've done. So the foundation appreciates donations. We're a nonprofit-driven nonprofit organization. So if there's interest in the project I just mentioned or possibility of participating, I'd like to hear from you. Otherwise, if you have any other questions about my presentation, I'm welcome to try to address those the best I can. So the floor is open.